fast because everything is manageable. Whereas SaaS, everything is. So when you run something,
no, the process right now is enforced.
what I need to do is take this results.
Hi, I'm Alex Keller. This is the project I've been working on all summer. So essentially our project was designed to take these million-dollar networks that critical infrastructure have been deploying and find a cheaper way to get it done. Personally, while working on this project, it's been a lot of fun. I've met a lot of interesting challenges trying to simulate these really complex, large-scale networks. It's not easy. But I feel I've learned a lot from this, and it's really taught me a lot about the way critical infrastructures like smart grids work.
The problem?
Oh, well, the problem is effectively these large infrastructures are trying to roll out large-scale networks, and unfortunately they're really expensive. They cost a lot of money to the people who use these infrastructures and raise the price of services. And so we're trying to lower the cost.
Okay,
Go ahead.
the map here. Can you
Oh, that. This is a demo, essentially. This is kind of a mock-up version of what our simulator looks like.
So what do the different labels mean?
So this is a mock-up of our simulator. So right here we have an epicenter. Now the epicenter in this case is a fire alarm. We've determined that downtown the parking garage has a fire alarm, and they've set that off. So these three cars, as they were driving by, managed to hear this message and went through an election process to become the first-party rebroadcasters. Now their job is to essentially take the message that they heard from the epicenter and send it again a little bit farther out. So you can see here, these are the 3 points that they did. And then more cars, as they were driving by, all heard that message and again resend it. So it's this sort of store and rebroadcast model. So sort of I tell a friend, they tell a couple of friends, they tell friends, and soon the school knows your secret.
Very nice.
Can you elaborate on the alerting protocols?
Yeah, sure. So the alerting protocol we've decided is the common alerting protocol. This is currently a protocol about 4 years old now. It's mainly designed to carry alerts on a national scale, so such things as weather alerts, amber alerts, and natural disaster alerts. And so what we've essentially done is we've decided that this would be a great standard to implement because it allows us to not only carry these protocols, but also to bring in these sorts of emergency problems. So things like fire alarms, gas leaks, ruptured water mains, emergency vehicles. You can read the list, but we envision this as a very common, ubiquitous way to alert people of problems.
Describe this diagram for us.
Sure. Yeah, so this is a diagram that basically describes what a VANET looks like. So a VANET usually consists of two types of cars. You have just your ordinary car. This is the sedan your mom and dad drive. And then we also have this smart car. You know, location-aware intelligent vehicles is what a lot of people refer to them as. And these are just your ordinary car, but now it has a wireless radio. This allows it to talk to things such as roadside units. And through these roadside units, it allows them to contact things such as external networks or services, like the internet or, you know, a telephone pole.
Very good.
So what is the conclusion of your research?
So far the conclusion of our research shows that we can absolutely lower the cost. These networks are being deployed already. A lot of companies like Google, Microsoft are looking into these technologies, especially with their autonomous vehicles, the ability for autonomous vehicles to talk to themselves. So we just see that this could be one additional, if you want to consider it, an app on top of this existing technology.
Yeah, one thing I want to understand is roadside units. So what type of network protocols are they using?
So the entire VANET sphere operates on a protocol called 802.11p. It's a Wi-Fi standard, so it's very much like the Wi-Fi you connect to, but the P represents specifically this sort of extremely fast, no setup time, really weird Doppler shift effects, essentially, are taken into consideration with this protocol. This protocol runs as the layer 1 protocol, and then at layer 2 they have an entire protocol suite called Wave. It's very much like Ethernet. And the Wave protocol allows you to send and receive messages in a very broadcast fashion without addressing. And so we've essentially had to create protocols on top of those two specific standards to carry our way out.
Cool. Awesome. That's our clip.